next solution we'll be talking about is fit and assembly. In the world of prototyping, there are three very common initial testings that take place. The first is form, also called concept modeling. It's very basic. It's just a visual appreciation of the model at hand. The second one is functional testing. Has different levels. You have initial function testing, you have more advanced functional testing, where you test the prototype in its environment. And the third testing that we'll be talking about here is regarding fit testing and assembly. Now, fit testing and assembly with Objet is really a perfect match. The reason for that is the following. We create high-quality parts. And those high-quality parts allow for thin walls to be created with great tolerance of just 0.1 millimeters plus minus, which is above standard within the industry. Those things together allow for parts to be printed and then assembled. It allows for fit testing to take place. So say you're in the consumer electronics world, you have a shell, you fit into the shell your electrical parts, your battery components, and the thin walls that exist in that prototype allow for those tests to take place. Objet really shines when it comes to fit testing. In fact, from all the applications that we offer our customers, fit testing is the most commonly used one.
Kinematics was developed to generate experience around the themes kinematic, robotics, and energy technologies for kids and make this world intuitive and conceivable. It contains active and passive elements with geometries that are based on pedagogic basic geometries like a cube, ashlar, cylinder, and triangle prism. Fit and assembly tests are important to verify that parts designed in the CAD environment can be smoothly assembled together. Issues such as dimensions, tolerances, and mechanical properties of the assembly parts are checked and reviewed. Often, changes are made in the CAD design or material selection due to flaws detected during this crucial phase in the product design life cycle. By printing models quickly and accurately, one can examine design strengths and weaknesses to fix mistakes before production starts. Kinematics is a construction game that enables you to set up, construct interacting moving objects, and is an excellent example of fit and assembly testing with full-cure materials. The simple plug-in connection enables data and electrical flow between all modules. This permanent connection allows many different construction forms with numerous dependent possible moves. Kids collect and increase their own experiences by playing, experiencing basic interrelations between construction, moving, and the use of energy with a permanently changing object. They develop a feeling for balance and train their abilities for coordination. Because the kits will be used mostly by kids for the first prototypes, a material with strong mechanical properties was necessary. The first prototype was printed in Full-Cure 720 and the second series in Vero Gray. A moving object needs to absorb a lot of forces, and Full-Cure 720 provides high mechanical stability and good impact resistance. The large number of combinations inspires users to reconstruct the entire object again and again and observe the changes. The kinematic block construction kit with moving modules requires highly precise and accurate 3D print parts because of the implemented electronics and mechanical elements. For instance, the small servos, microcontroller, and batteries must fit perfectly into the modules. The results show all different modules fit perfectly together. The sensor modules allows an interaction between the environment, the playing person, and the object, and develop a feeling for balance while training coordination skills. To sum it up, the kinematic story is an excellent example of the use of 3D printing models to test fit and assembly of parts early in the design stages.